Okay, so we have this spatial panel in which we can adjust some parameters, and we have a slide deck here that is very tiny. In the slide deck, we explain that we built an app using MetaQuest 3, which is the VR headset I'm wearing right now, and Muse 2, which is a headband that does EEG readings so that we can integrate brain signals, and we used eigenlayer AVS as the main bounty. So the app we proposed here shows how neural interfaces will be integrated into Web3. Not necessarily now, but perhaps later when better brain interfaces are developed. You see some cubes in front of me. When I lift up one of these cubes, you see that there is a predictor line beneath it, and it's not very stable. So with Muse 2, we can actually calculate how unfocused or stressed one person is relative to how calm they have been in the last 30 seconds or not. That device is often used by people who do meditation and so on and want to improve themselves in it to achieve like calmer tones. And this app of ours would say, okay, when I throw the cube around and play with it, I want it to be kept stable by the platform beneath it. But the platform beneath gets random voice added when the Muse 2 detects that I am under stress or I am unfocused. So what's the problem here? The problem is when we build this app the way it's conventionally built, even if we turn this into a multiplayer game with different functions and so on later on, we would have a centralized server that makes use of people's neural data directly, which is not very welcome in the Web3 culture. Instead, what someone could do is, whenever I'm moving the ball, it's not connected to any Web3 fashion, but whenever Muse 2 does some EEG readings from my brain, then what would happen is, instead of a centralized server in the game processing whatever's happening, we would use, for example, the eigenlayer AVS for, well, making sure that the computation takes place in this centralized fashion. So the input would be raw data that's taken from the brain, and the output would be how much noise should be added to the predictor that's beneath the cube. And what's in between would be achieved by the Web3 solution. Maybe right now this isn't very useful. For Muse 2 is a very incomplete product, so to say. But when Musk's company, let's say Neuralink, comes up with a newer solution that's a more explicit brain interface, then it will only add to the confidentiality of the neural data, and just using conventional security means such as RSA will be limiting in terms of what types of processes can take place in decentralized fashion, and also who gets to see them and track them and so on. We didn't need to use eigenlayer AVS, but we chose to use it because it was enabling thereof and more scalable in some ways, maybe.